Okay, so now I'm somewhere in the middle of the processing. So I want to do a check if the system is up and running and it's continuing to process, evaluate the progress, maybe look again at some dashboards. And since in the first part I kind of reviewed the architecture, now I would like to dive deeper in the code and how I approach the problems, maybe some problems I encountered, and finally I will round it up with some conclusion when all the processing is done. So to see what was accomplished and reflect on things that I can improve to finally reach that goal of processing 100 images per second. But now I think it's already some nice progress. So let's see where we stand. I would have loved to build a progress bar or something, but it's also nice to practice some CLI commands and to uh, do it while the software is in production. So quite a few images to process. I'm expecting somewhere around 20,000 out of 50,000. So yeah, 21,000 images were processed, maybe a bit more since I have also other extensions. Let's see in terms of labels, how many labels did we manage to generate? So as a reminder, like the labels were all the objects that were identified in the images, and the processing also had the face detection part. So here, quite a big discrepancy. So probably those errors we were seeing. And for faces, okay, this grew a bit in the meantime since it's still running, but this one is a bit more closer to the actual number of images. So it seems that face detection is working quite well, but for labels I'm getting a lot uh, of unlabeled images. So again, let's walk through the problem. So I had the indexing model. My first attempt was to write the indexing model in Python, Node.js, and PHP, and kind of compare how I feel and what the final solution would look like. Uh, it was also a matter of preference, but I stick with Node.js for the rest of the exercise. So both the ingest and the processing module were written in Node.js. Now, getting back to our diagram, the indexing was what was quite interesting to build. Since the files were quite large, you don't want to extract to read everything in the memory. So there was quite some trial and error with some node modules for reading zip files. Uh, and one of them was loading everything in memory. So that was not an option. So I stick with one that could stream the file and then read the content uh, as I was needing it. So also a bit of processing to determine what I want to extract, since the archive added more files, and some logic to post the data. So now if we are looking at the code, which is still crunching photos, I have the function to post the data, the function to read the zip file, and I'm getting a path for where the zip files are stored. I'm globbing them and retrieve all the zip files from that directory, and then for each of that file I'm reading the content of the zip file. So reading was quite straightforward with this library stream zip that would load everything asynchronous. I figure out that waiting for each image to be posted wouldn't be that efficient, so I kind of implemented the logic of batching. So taking a slice of the images that I found, matching them to the extension, and then push a promise in the batch. And once I reach the batch size, I would wait for all those promises to settle, and then wait for 1 second. So this is how I kind of organize the flow of data. And finally, the post data is just a simple function that takes the file. It encodes the file in base 64 so that I can send it on HTTP, and makes a post request to the ingest file. So this was quite a simple function, just reading files from disk, extracting the archive one by one, and posting them to the ingest module. Good. Let's move forward with the ingest module. The ingest module, I wanted to be a bit more organized, so I've also wrote some tests and also wrote some mocks for those tests, since I have a lot more functions to process. It's just a simple express framework that exposes an upload endpoint, and this endpoint is decoding the image, saves the file to S3, and then sends a processing event to a lambda function that then adds that event in the queue. So from what we saw in the first part, this is a part that breaks, since that lambda function needs to handle more load. There's a better approach to do it, to use a notification system. I also wrote some code for that, and I could have used it, but couldn't do it until the deadline, so I settled for less processing power. This was quite interesting to test and mock. So because I'm relying on so many AWS services, I don't want to call them directly, so I had to practice mocking on them, also for saving files, mocking the implementation from reading, and all the node modules for handling files was an interesting exercise. Created mocks for the UUID module to make sure I'm getting the data I want, and in the end putting it all together in some integration tests. So here I'm mocking the save file, and I'm making the requests to my endpoint and testing for different variation of data. Last part was where the fun began. So the processing, I wanted to get some experience with serverless. So this gave me the chance to work with the serverless framework. Serverless puts a nice configuration around all the resources that you can provision in AWS or other cloud providers. I saw a bunch of them in the documentation. And with this YAML file, you can construct your serverless infrastructure. So for my need, I had followed the template they are already providing, where you can create a queue. This queue is handled by a worker. So we see the publishing and subscriber pattern here, and it also exposes a producer. So this would be where the publishing happens. This publisher will, let's dive in the code. The producer will take some payload and put that message in the queue. And then the second lambda is the consumer that just waits for the records to arrive in the queue. And here is where I implemented the logic to save some metadata of the file, then to detect faces and to detect the labels. And for the two functions, there was not too much to implement. I've implemented the commands from Amazon recognition, getting the response, doing some error handling, and then finally saving the images under the S3 bucket that I configured. Yeah, so these are the pieces of the puzzle. Now maybe we can look a bit at the monitoring dashboard. It's been quite steady. It seems that I had some hiccups at some point with an increase of speed, but there's been some steady throughput in the last minutes of running. So maybe it would be interesting to see where we are now. Also, serverless gives you some nice overview on how things are going. So we already see 45k invocations. So we kind of have to double it because it's one invocations for the producer and one invocation would be to consume the worker. So it runs out to what we saw in the number of image processed. So this has been quite steady. Let's get back to also to the CloudWatch. Yeah, this is also quite consistent, but we see those detect labels failing. Sorry, I forgot to get back on the screen. So previously I was showing you the serverless dashboard. Yeah, quite a challenge to record and present in the same time. I have a nice OBS setup to make it work. Yeah, so now I'm kind of halfway to the processing of all files. We went through the code and looked a bit on how the implementation of was done. Got back to the monitoring dashboard, see that everything runs steadily, and yeah, in the end, I will come back with some conclusions, maybe do also some analysis of what was achieved, like how stable the system was. I already see the labeling didn't work quite well, but in the end, I'll round it up with the conclusions. See also the cost is very important, how much everything costs, and yeah, leave it from here. So here ends the second part. Bye bye.